Hi, this is Ethan from HorsepowerCalculators.net, and today we're going to be tuning a 2010 BMW M5. Let's talk a little bit about the stock engine. The 2006 to 2010 BMW M5 is a 5-liter 500 horsepower V10 engine. It has an 8,000 RPM redline, produces 500 horsepower at 7,750 RPMs, 383 foot-pounds of torque at 6,100 RPMs, which is a high RPM range or a high RPM point to produce your peak torque, but that's because of the short stroke of this motor, which we'll see in a second. It has a 40 valve dual overhead cam, so it's got 4 valves per cylinder. It has a 92mm bore and a 75mm short stroke. The compression ratio is 12:1, and it's a naturally aspirated engine. In stock trim, the car can reach a top speed of 203 miles an hour or 327 kilometers per hour with the limiter removed, and it does a 0 to 60 or 0 to 100 kilometers per hour in 4.7 seconds. Our goal today, in today's tuner report, we're using the Supercharger Calculator to design a complete one-off supercharger system for the BMW M5. The engine has been successfully tuned by G-Power to over 800 horsepower, and that was in their efforts to break their top speed record of 372 kilometers per hour or 233 miles per hour. So our goal today is similar to theirs. We're going to use the performance calculator to find the exact power level required to reach our target top speed of 373 kilometers per hour and our acceleration time of 4.35 seconds for a 0 to 60 time. We're then going to use the Supercharger Calculator to extract over 800 horsepower safely from this motor using a pair of centrifugal superchargers similar to the ASA T13s used by G-Power, and the G-Power power plant is also rebuilt with mal-forced pistons and upgraded connecting rods. This gives it a stronger bottom end and a lower compression ratio for the boost level, and then peak power is delivered at 8,000 RPMs instead of 7,750. So we're going to use the same parameters that they used to design our version or our BMW application. Right, now that we have our stock parameters and we have our power goals, let's move to the horsepower calculator. As you can see here, I've already logged in. This is the first page of the power calculator, which I call the performance calculator. The performance calculator can help you decide how much power you need to reach your performance goals. And here we're looking at a 500 horsepower engine that in stock trim runs a 4.7 0 to 60. Our target 0 to 60 is 4.35, just like the G-Power. Our top speed in stock trim, let me go back and check, 203 miles an hour, 327 kilometers an hour, 203 miles an hour, and our new target, let's go back and check one more time. Our new target is 233 miles an hour. Click on Calculate, and you see the results here. To reduce our 0 to 60 time from 4.7 to 4.35 seconds, we're going to need at least 540 horsepower. And to increase our top speed from 203 miles an hour to 233 miles an hour, we're going to have to increase our horsepower up to 756 horsepower at the least, which is pretty close to G-Power's estimated number of 800 horsepower. Now, the reason the G-Power isn't faster on its 0 to 60, even though it's producing much more than 540 horsepower, is that 0 to 60 requires good traction, and if you have a lot of horsepower, then you might lose some power in traction, so you won't see your times reflecting your power level. The other thing is that we're using centrifugal superchargers that build boost as you get higher in the RPM ranges and as you get closer to redline. So when you do a 0 to 60 run and you use a wider range of RPMs, then the added power or your average power increase from the supercharger isn't going to be as high as your peak power increase, and so your 0 to 60 times aren't going to improve as much as, say, your 60 to 120 or your top speed numbers, because most of the power adding or most of the boost pressure is concentrated near redline, and that'll show more on top speed racing and the top end of your drag racing after the 8th mile, rather than showing up in your short sprints like your 0 to 60. So now that I know what my power goal is, I'm going to click on Next. My engine is a 5000cc V10 cylinder with an 8,000 RPM red line. It has dual intake valves, dual exhaust valves, a 91.9 millimeter bore, stroke, let me check again, 75.2 millimeter stroke. Compression ratio is 12 to 1. In stock form, it produces 500 horsepower at 7,750 RPMs at 0 pounds of boost because it's naturally aspirated. I would like to make, I said, about 785 horsepower when I did this calculation beforehand. Planning on running a single throttle body and a true dual exhaust system. And I'm planning on a supercharged buildup. Those are my inputs. Click on Calculate. Here on the Advanced tab, I'm going to come down to Superchargers and I'm going to choose Twin. So we're going to use a twin supercharger arrangement. And I also have the option to change my bore, my stroke, and my compression ratio, which I'll do in a minute. We're going to come back to this. 12 to 1 is obviously a high compression ratio and it's not very boost friendly. Just going to click on Next, which will give me my results. If you look at the results here, I think I made a mistake somewhere. Let me go back. Yeah, it's a 5,000 cc, sorry. I made the same mistake when I was doing the report. Just click on Next. Twin supercharger, click on Next. Okay, these are the correct results. Expected bolt-ons power, if you take peak power from 7,750 to 8,000 RPMs, is 513 crank horsepower. Maximum safe red line, 9,720 RPMs. This comes directly from the short piston stroke and having an overbore engine, an over square engine basically. And so the piston doesn't have to move a long travel distance, and it has a very low average piston speed. So this engine can be safely used at a higher RPM. But we are not going to do that today because it would require new camshafts, new valve train, new engine control system. We're just going to stick to the 8,000 RPM limit. If you look here, I'm going to reach this power level at 7 pounds of boost, and my recommended static compression ratio is going to be around 10 to 1 for 7 pounds of boost. So my calculation isn't finished here. I'm going to have to go back to my Advanced tab and say that I'm going to lower my compression ratio to about 10 to 1. Because I know I'm going to run about 7 to 9 pounds of boost, and that's what the calculator recommends. When I lower my compression ratio, I'm going to take a slight hit on my power level, about 4% per compression point. So we're going to have to compensate for that drop in compression with more boost to reach the same power goal. Just click on Next again. You'll see the results here. The calculator says that I now need 9 pounds of boost with a compression ratio of 9.9 to 1 to reach my power goal, which is accurate. These are the remainder of my results. I can tweet this at Power Calculator. Let me just tweet this to our stream. Tweeted successfully. Click on Next. Next. Okay, there we go. Here's the illustration of my intake and exhaust dimensions. It's going to use a large diameter exhaust runner, almost a 2-inch runner, and a dual 3-inch catback exhaust system for this power level. Also gives me my intake manifold and intercooler dimensions. Click on Next again. Here's my cylinder head parameters. My intake valve, or my intake side, has to flow 234 cubic feet per minute. And I expect my valve diameters to be a 34 millimeter intake valve and a 29 millimeter exhaust valve, so you can know whether or not you're going to likely need to upgrade your head for this performance level. Click on Next again, and here are my superchargers. You can see the ASA TM15. If you don't want to use ASA superchargers like G-Power did, you can use Vortex superchargers. You can use other centrifugals like the Rotrex C3861 trim. All of these superchargers here used in a pair will be able to deliver more than 700 horsepower. You can see each of these can deliver about 460 horsepower, so a pair of these will deliver about 900 horsepower, and so you won't have your supercharger maxed out when using a pair of these. You'll be in a good point on the compressor map with a high amount of efficiency. Alright, so those were our calculations. I I guess there's nothing else to cover here. I'm Haytham Hamsi, and thanks for tuning in for our second tuner report where we tune the BMW M5 up to 800 horsepower using our performance calculator to estimate our power targets, and using our Supercharger Calculator to design our twin supercharged system for this V10 engine. Thanks a lot. Until next week, take it easy.